Welcome into another lesson, everybody. Today we are going to talk about areas of parallelograms and trapezoids. Let's start with a parallelogram, what one is. So here is a parallelogram, and if you see it, it's a four-sided figure. You might be saying, well, that looks almost like a tilted rectangle. Basically it is. In a rectangle here, I'm going to draw a rectangle next to it. A rectangle has four perfect right angles, four perfect corners. These things I'm drawing denote right angles, four perfect corners. In a parallelogram, you don't have that. You have uneven corners. So also, we need to talk about parallel lines, because in a parallelogram here, both sets of opposite sides are parallel to each other. When two lines are parallel, I'm going to write the word parallel, they never intersect. They never cross. They never touch. They just keep going on to infinity. You could draw it out to infinity, both lines. They would never touch. They would never intersect. Same with the other two sides here. These two sides, they're parallel to each other. You keep going to all creation, all infinity, and you would find that they never intersect. A rectangle is actually the same. You have two sets of parallel lines. They never intersect. A rectangle is a special type of parallelogram. A rectangle is a parallelogram because it meets all the criteria of a parallelogram, having two sets of opposite sides being parallel to each other. They just happen to have right angles. Whereas a parallelogram is not a rectangle. It's not a rectangle. It just simply got two sets of opposite sides that are parallel to each other. So that's how you determine what a parallelogram is. Now let's see here. You have the base. You have some other side. We need to figure out the height, though. The height can be anywhere on the parallelogram. It's got to be a straight down line. A straight down line. None of these slanted sides could be your height. Remember, the height has to be a straight line. So, if you want to find the area of a parallelogram, it's simply the base times the height. That's all a parallelogram is, the base times the height. So, let's say here that we have, for the base, we have 20 meters. For the height, we have about 15 meters. Right? I want to find the area. It's just the base times the height. So the base is going to be 20 meters, where the height was 15 meters. So you'll have 20 times 15, which would be 300. Meters times meters, that's meters squared. So the area of this parallelogram is going to be 300 meters squared. And that would be your answer. Alright. So remember, these slanted sides of the parallelogram cannot be your height because they're slanted. You have to have a straight line in order to have a height. So let's say we have 40 feet for this base. Let's say we have 30 feet for the height. Again, the area of a parallelogram is nothing more than the base times the height. The base in this case is 40 feet. And then the height we determined was 30 feet. Well, 40 times 30, that's going to be 1,200 or 1,200, however you prefer to say it. Feet times feet, well, that's just feet squared. So the area of this parallelogram is 1,200 feet squared. And I think parallelograms are easy enough to understand. It's almost like finding the area of a rectangle. Basically the same formula. The only difference is, in a rectangle, you could take the width and make that your height, basically. Whereas in a parallelogram, you got to find the height. You got to have the height from inside of it, because the slanted sides cannot be your height. You have to have a straight edge for the height. Alright, then we set out to talk about trapezoids today. Let's talk about trapezoids. Now I could draw that a little bit better. In case you all haven't figured out yet, I'm not the world's best artist. Okay, we have a trapezoid which looks like this. So you have two bases, both parallel to each other, then you have the legs on the side. So I'm going to introduce subscripts today. You have B1 and B2. So what subscripts are, it doesn't do anything to the value of the base. All it is it just denotes base 1 and base 2. And when you have two or more of the same type of thing, you sometimes want to introduce subscripts. If it were a power, it'd be up here, but we're talking about subscripts, which are down here, which does nothing to the it does nothing to it. It just simply denotes which base is which. Alright. So, again, in a trapezoid, the bases are parallel to each other. So that means they could go on forever. They'll never intersect. They'll never touch. And then the height, much like in a parallelogram, well, you can't use the slanted legs to be a height. The height's got to come from somewhere in here. That's your height. So, to find the area, if we were talking about perimeter, you just add up all the sides together. If you're talking about area, it's equal to 1/2 times the height times the sum of the two bases. That's the area of a parallelogram. It's going to be half the height times the sum of the two bases. So we'll start out here. Let's say the first base is 10 inches. 10 inches. The second base is 25 inches. And then the height, we'll say that's 8 inches. The height would be 8 inches. So, in order to find the area, again, it's going to be equal to 1/2 times your height, which in this case is 8 inches, times the sum of your two bases, which would be 10 inches plus 25 inches. Alright? Well, of course, according to the order of operations, we first start with what's in parentheses. So you'll have 1/2 times 8 inches. Now, what is 10 plus 25? That's 35 inches. Alright, now we can do multiplication from left to right. 1/2 times 8, that's going to be 4 inches. So we have 4 inches times 35 inches. Now just simple multiplication. 35 times 4 happens to be 140. An inch times an inch, that's inch squared. So the area of this trapezoid is 140 inches squared, or 140 square inches. Alright, I'll have another example here. Leave the area formula up for you. let's say we have 35 centimeters for your first base. Then it'll be 85 centimeters for your second base. Your height would be 50 centimeters. I'm just making up some values here, of course, but we have a trapezoid with the first base, the top one, being 35 centimeters, the second base, the lower one, being 85 centimeters, and the height being 50 centimeters. Because once again, these slanted legs of the trapezoid cannot be your height. You have to have a straight line for it to be a height. So we'll start out here. Let me see if I can find a better marker, huh? The area, there we go. Area is equal to 1/2 of the height, which was 50 centimeters, times the sum of your bases, which would be 35 centimeters plus 85 centimeters. Well, of course, according to the order of operations, we do what's in the parentheses first. So you'll have 1/2 times 50 centimeters. Now we need to add up 35 and 85. Last time I checked, that was 120. So that'd be 120 centimeters. Now we can just do a straightforward multiplication problem. You have 1/2 times 50, well, that's just going to be 25 centimeters. You'll have 25 centimeters times 120 centimeters. Which, if you multiply 25 times 120, you'll get 3,000. And the centimeters times centimeters, that's centimeters squared. So the area of this trapezoid is 3,000 centimeters squared. So really there isn't much to these. I suppose we could do one more for trapezoid, because trapezoids can be a little bit funny. Parallelograms are pretty straightforward, just base times the height, but when you're introducing something such as a trapezoid, that can be a little bit funny sometimes. Alright, let's say we got 10 miles for the bottom base, 3 miles for the top base, and then 6 miles for the height. 6 miles for the height, okay? So again, find the area of the trapezoid. It's going to be 1/2 times your height, which was 6 miles, times the sum of your two bases, which would be 3 miles plus 10 miles. Okay? Of course, according to order of operations, do what's in the parentheses first. So you'll have 1/2 times 6 miles times 3 plus, we got 3 plus 10, well, that's 13 miles. Now you just do the multiplication. What do we got here? 1/2 times 6, that's going to be 3 miles times your 13 miles. Now what is 3 times 13? That's 39. And then miles times miles, that's miles squared, or square miles. So area of this trapezoid is 39 square miles. And that's really all there is to finding the area of a trapezoid. You just take 1/2 times your height times the sum of your two bases, and that's the area of a trapezoid. And remembering that the slanted legs cannot be your height. The straight line somewhere inside the trapezoid would be your height. So next lesson we're going to get into circles. We will talk about finding the perimeter and area of a circle. Or in a circle, the perimeter is called circumference, but we'll get into that next lesson. I hope everyone has a good day. Take care.